The sky never warns us. It never shouts or flashes a sign. It just waits, holding its secrets in a calm so deep it can feel ancient. And sometimes, if you're paying close enough attention, you can hear it whisper through the smallest flicker of light. For months, astronomers kept their eyes on a dark traveler drifting toward the inner solar system, an interstellar visitor known as 3I/Atlas. At first, it looked ordinary, almost peaceful, like a silent stone wandering through space after a journey too long to imagine. Every night, telescopes across the world followed it along the ecliptic, the thin, invisible line where our planets glide in a quiet cosmic dance. Nothing seemed unusual. Its speed was steady. Its angle was predictable. Its glow fit every model perfectly. It looked like a frozen, harmless fragment from somewhere far beyond our sun. But space loves to change the story when no one expects it. One evening, as new light readings came in, a tiny irregularity appeared in the data. It was so small that most people would have ignored it. Just a slight bend in the light curve, barely a ripple. Software flagged it as noise. A glitch. Static. But astronomers learn early on that the universe often speaks through the smallest mistakes. A young grad student noticed the pattern first. She had been staring at a glowing screen for hours when she saw the comet's brightness dip and rise again, soft and uneven, like a heartbeat struggling to reach the surface. She told her supervisor, who shrugged it off, but she insisted they check again. When they did, the distortion was still there, hiding in the data like a secret refusing to disappear. It wasn't proof. It wasn't even a discovery. It was more like a question, faint but persistent. Days passed, then weeks. More observatories began watching 3I/Atlas. For a while, nothing strange appeared. No sudden flares. No odd shapes. Just a silent traveler drifting through the dark. But then the light curve bent again. Not in the same place as before, but close enough that every scientist in the room felt something tighten in their chest. It was the kind of moment that feels like someone tapping your shoulder in a dark hallway. Gentle. Almost polite. But you know it wasn't random. They plotted the data again. The curve was supposed to be smooth, shaped only by sunlight reflecting off dust and ice. Instead, the line twitched. Not wildly. Not like chaos. It twitched with precision, as if something was sliding in and out of view behind the comet. Blocking the light. Releasing it. Blocking it again. Something unseen. Something riding with it. Some blamed dust jets or strange surface angles, but every explanation fell apart under the numbers. The changes were too clean to be accidents. Too consistent to be random. Almost like tiny signatures written into the curve by hands no one could see. And slowly, a quiet unease spread across the scientific community. No one dared call it an anomaly, yet, that word changes careers and invites scrutiny. Instead, they used softer language. A deviation. A curious effect. A small inconsistency. But underneath the careful words, they all felt the same cold suspicion growing. Something didn't add up. As 3I/Atlas drifted closer to the sun, the distortions sharpened. Each new night of observation revealed more detail. The object's reflectivity shifted in a way that didn't match natural motion. It was almost as if the light wasn't bouncing off the comet at all, but off something hidden in its shadow. Then came the night that changed everything. A telescope in Chile captured the clearest reading yet, a pulse. Not a dip. Not a flare. A pulse in the light curve. A slow rise and fall, subtle but rhythmic, like a soft breath pushing through the dark vacuum. The pulse repeated. Not perfectly, but close enough that the room fell into a heavy silence. Someone finally asked, in a shaky voice, "Is this real?" To be sure, they checked everything. They recalibrated the sensors. They cross-referenced data with observatories thousands of miles away. Every independent reading showed the same gentle pulse, the same light curve bending under something that shouldn't be there. The idea no one wanted to speak out loud began to spread through the room. Could something be traveling with the comet? Could something be attached to it, or orbiting it, or hiding behind it like a ship tucked behind an island? No one said it. No one dared. Scientists don't jump to conclusions. They don't chase shadows. But when they looked again at the brightness curve, at the faint shape moving inside the data, the question refused to die. What kind of natural object leaves a shadow that moves on its own? As days turned to nights and nights to days, the pulse stayed with them. Always faint, always right on the edge of disappearing, but never gone. It was like a tap on the shoulder you couldn't catch, a whisper you couldn't locate. Every time they thought the signal might fade, it returned with the same steady rhythm. The comet moved closer. Deeper into the sun's light. And with each mile it traveled, the sense of dread grew stronger. The universe is full of odd objects, but it doesn't often pretend. It doesn't hide on purpose. Yet here was something that felt like it was performing. Like it was choosing when to appear. As if the pulse wasn't just happening, but happening for us. By the time 3I/Atlas reached the inner system, the mood around it had changed. The early excitement had faded into a quiet fear. No one understood the distortions in the light curve. No one could explain the pulse. But everyone felt the same uneasy truth rising from the data like a cold tide. Something was waiting. Not announcing itself. Not revealing itself. Just watching from the darkness behind a wandering interstellar object. And as the comet drew closer to the sun, telescopes around the world prepared for better readings, clearer views, and maybe, finally, an answer. But the question that echoed through every observatory was simple and chilling. If something really is hiding with 3I/Atlas, what happens when it comes closer? The sky didn't say a word. But the light curve kept bending. And whatever was waiting out there had only just begun to show itself. Sometimes, the universe speaks in whispers so small that we don't hear them at first. We shrug them off, call them mistakes, and move on. But every now and then, a whisper becomes a rhythm, and refuses to be ignored. That's exactly what happened as 3I/Atlas drifted deeper into the inner solar system. At first, the strange flickers coming from the object looked harmless. Just tiny bumps and dips in the data. The kind you see when a sensor twitches or a cloud drifts in front of a telescope. Nothing that would make anyone lose sleep. Most scientists marked the readings as errors. Glitches. Maybe even dust on a lens. And for a while, that explanation felt safe. Clean. Comfortable. But comfort doesn't last long in astronomy. A team in Hawaii noticed it first. A small pulse in the brightness, faint, quick, almost too gentle to catch. They flagged it in their report but didn't think much of it. Then a telescope in Spain saw the same pulse. Same shape. Same timing. Same strange rhythm hiding in the light like a soft knock on a distant door. Still, even then, nobody panicked. Coincidence happens. Data overlaps all the time. But then came the third observatory. And the fourth. And by the fifth, the room grew still. Because the pulse wasn't just repeating. It was sinking. Down to the millisecond. A tiny rise in brightness. A soft fall. A pause. And the whole thing repeated like a heartbeat that didn't belong to nature. One scientist stared at the graph for a long time before whispering, "How is that possible?" The room didn't answer. It couldn't. Because in the world of natural objects, comets, asteroids, icy debris floating through the dark, nothing pulses in perfect rhythm. Nothing syncs across the planet like a conductor leading an orchestra. Noise is random. Mistakes are messy. Errors do not keep time. But this was different. Soon, screens across the world lit up with the same pattern. From Chile to Japan. From Arizona to South Africa. Every observatory that pointed at 3I/Atlas recorded the same clean, repeating pulse. No drifting. No fading. No chaos. Just a quiet, steady beat hiding inside a river of starlight. It felt like hearing someone breathe on the other end of a phone call you thought was silent. At first, scientists tried everything to prove the pattern wasn't real. They tested software, checked cables, recalibrated mirrors. They even switched off systems one by one just to make sure nothing unusual was happening inside their own machines. But the pulse kept coming. Every night. Every observation. Every angle. The more they tried to break it, the stronger it seemed to become. Like the object wanted to be noticed, but only by those patient enough to listen. Eventually, a small group gathered behind a monitor, watching the repeating curve in complete silence. For a long moment, no one said a word. Then someone whispered the question that had been sitting in the room since the first pulse appeared. What if this isn't noise? That single sentence changed everything. Because if the pulse wasn't noise, then it had a purpose. And if it had a purpose, then something was creating it. Still, no one dared say the word signal. It felt too heavy, too dramatic, too final. Saying it out loud would make it real. And no one was ready for real. So they called it a pattern, which felt safer. A repeating sequence, which sounded neutral. But every person in that lab felt the truth pressing in behind the softer language. Patterns don't repeat in perfect timing by accident. Not in nature. Not across multiple observatories scattered across the Earth. When they mapped out the pulse, the rise, the fall, the pause, something even stranger emerged. The spacing between each bright peak wasn't random. It followed a ratio. A clean, beautiful ratio. The kind mathematicians fall in love with. The kind engineers use. The kind that serves a purpose. Some people stared at the numbers in quiet disbelief. Others looked away, almost afraid of what they might be seeing. But the feeling spreading through the scientific world was the same. This wasn't just a comet anymore. Something about 3I/Atlas had shifted from mysterious to intentional. The deeper they looked, the more eerie it became. The pulse didn't change with the comet's distance. It didn't wobble when 3I/Atlas rotated. It stayed steady. Unbroken. Like it didn't care about the comet at all. Like the comet was simply the carrier, not the source. As that idea took shape, people began asking questions they never thought they'd have to ask. Could something be embedded in the object? Could something be orbiting it, small enough to hide in its shadow? Could something be using the comet's path as a mask? Or, in the quiet corners of late-night meetings? Could it be transmitting? The conversations grew heavier. Rooms felt colder. Something about the pulse carried a weight no one could shake. It wasn't loud. It wasn't bright. But it was unmistakably organized. One scientist compared it to tapping your finger on a table, slow and steady, hoping someone in the next room hears you. Another described it as a lighthouse signal, flashing across the black ocean of space. Not enough to scare. Just enough to be seen. And once you see it, you can't unsee it. As the nights passed, people who had once dismissed the readings found themselves staying late, drinking cold coffee, eyes locked onto the pulse that refused to go away. It was hypnotic, in a strange, unsettling way. A tiny piece of order hidden inside a sea of chaos. Some couldn't sleep. Others couldn't stop thinking about it. And soon, a new kind of fear began to settle in, not the fear of danger, but the fear of not knowing. Because if the pulse was a signal, then who was it meant for? And what was it trying to say? By this point, the pattern had a nickname. The beat. A soft, steady rhythm moving through the cosmos, carried by a wandering interstellar visitor. Scientists didn't understand it. They couldn't explain it. But they felt it, something about the pulse felt alive, even though they knew that was impossible. As 3I/Atlas continued its slow descent toward the sun, the beat stayed with it, unchanged, unbroken, unbothered by the rising heat. Observatories kept watching, waiting, listening. And in the quiet moments before dawn, many found themselves asking the same chilling question. If this isn't noise, and it isn't a mistake, then who, or what, is keeping time with us? The pulse didn't answer. It simply continued. Soft. Steady. Waiting for someone to finally understand. And whatever the truth was, it was getting closer. There are moments in science when the universe feels less like a place, and more like a presence. A presence that watches. A presence that waits. And sometimes, a presence that reacts. That realization hit scientists on a quiet night when a set of infrared telescopes detected something that shouldn't have been possible. Until then, the strange pulse coming from 3I/Atlas was weird enough. A repeating rhythm hiding inside the light curve, steady and patient like a soft heartbeat. But the moment they switched from visible light to heat imaging, the story changed. It was subtle at first. A tiny rise in temperature, almost too small to notice. But then the object cooled again. Then warmed. Then cooled. Slow. Smooth. Measured. And when they lined up those temperature swings beside the pulse they'd been tracking for weeks, every scientist in the room felt their stomach drop. The two patterns matched. Perfectly. It was as if the object was breathing. In light. And in heat. Nobody wanted to say that out loud, of course. Breathing wasn't a scientific word. But the way 3I/Atlas warmed and cooled felt alive. Intentional. Almost thoughtful. Like something hidden under its surface was powering up, then resting, then powering up again. One researcher blinked at the screen in disbelief. "That can't be right," she whispered. "Temperature doesn't do that. Not out there." And she was right. A comet doesn't warm in clean cycles. It doesn't cool on cue. It doesn't follow a rhythm like a musician keeping time in the dark. Natural objects respond to the sun in chaotic ways, dust jets burst unpredictably, surfaces crack and flare, shadows sweep across rough valleys. Nothing in deep space behaves like a perfect cycle. But this was a cycle. A quiet, careful one. Some scientists tried to explain it away. Maybe it was sunlight reflecting off different angles. Maybe a dust plume changed the readings. Maybe a glitch. Always the word maybe, holding the truth at arm's length. But the deeper they looked, the harder it became to pretend. They mapped the temperature changes across time, and the graph looked too smooth. Too clean. No random spikes. No messy edges. Just a gentle wave rising and falling again and again like the slow pull of a tide. It was almost beautiful. A few people in the room didn't know whether to smile, or fear it. The turning point came when someone overlapped the heat cycle with the light pulse. When both lines lay on top of each other, rising, falling, and pausing in perfect sync, the room fell silent. No chatter. No typing. Just a heavy, breathless quiet. Because randomness doesn't sync. Chaos doesn't keep time. Nature doesn't do this. One physicist leaned back in his chair, rubbing a hand over his face. "If this is natural," he said quietly, "then it's the most organized natural object we've ever seen." But even that didn't capture it. Organization was one thing. Precision was another. And this was beyond both. This felt like a design. A choice. A system. At that point, smaller questions began floating around the room, the kind spoken softly, as if saying them too loudly might make the answers real. Could something inside the object be generating heat? Could something be cycling energy? Could there be an interior rhythm, like a machine regulating itself? The word machine wasn't supposed to be spoken either. It carried too much weight. Too much speculation. But the truth was right there in front of them, pulsing on the screen with every passing second. Light. Heat. Light. Heat. Two signals. One pattern. One source. And as the reality settled in, something else began to trouble the scientists: the timing. The object wasn't heating from the sun. It wasn't responding to radiation or position. It was heating on its own schedule, independent of everything around it. Rising in temperature even when it traveled through pockets of cold space that should have frozen it even further. It was like something inside was waking up in intervals. Not constant. Not dying. Not drifting. Working. The more they watched, the more impossible it became to look away. Some researchers leaned in so close their breath fogged the screen. Others backed away, suddenly uneasy, as if standing too close to the data might somehow let it reach them. One younger team member whispered what everyone else was thinking: what if the heat isn't the object? What if it's something inside it? No one answered. The thought was too heavy. Too bold. Too close to something humanity wasn't ready to accept. Instead, they studied the readings again and again. They checked for interference, recalibrated equipment, ran dozens of simulations, but every test led to the same final, inescapable truth. The temperature cycle was real. It was deliberate. And it was tied to the same rhythm as the pulse they'd found before. Two different signals from one source. At that moment, everything they thought they knew about 3I/Atlas began to crack. The comet wasn't behaving like a comet at all. If anything, it was behaving like a device. A device with an internal process. A process that repeated. A process that controlled heat and light with mathematical precision. One veteran astronomer stepped away from the monitors, staring out the window at the night sky. He'd spent his whole career studying stars, planets, moons, the silent, predictable pieces of the universe. But this object didn't fit into anything he understood. "It's almost like it's trying to stay alive," he said softly. His colleagues didn't laugh. They didn't argue. They just kept staring at the graphs, following the synchronized waves rising and falling like two voices speaking in unison from across the void. As hours passed, one fear grew louder in the room, a fear no one wanted to say aloud. If this was a machine, if something inside was running in cycles, then the question wasn't just how it worked. The question was why now? Why was the object waking up as it drifted closer to the sun? Why did the pulse strengthen at the exact moment the heat cycle started? And why did the entire pattern feel less like a natural behavior and more like preparation? The scientists didn't know. They couldn't know. But the synchronized signals felt like a warning. Or a test. Or maybe even a message hidden behind layers of heat and light. As the cycle continued, repeating with perfect patience, one thought hung over every person watching. Something out there is active. Something out there is aware. And with every shift in temperature, it's getting closer to whatever comes next. The object moved on, quiet as ever. But the heat stayed with it. The pulse stayed with it. And the sense of something waking grew stronger. The sky, once silent, felt like it was breathing again. And whatever was behind those signals was about to show more. There's a moment in every investigation when the universe stops feeling distant, and suddenly feels aware. For the scientists studying 3I/Atlas, that moment arrived on a quiet morning, when a surface scan returned an image that shouldn't exist. It was supposed to show rough dust, broken rock, shattered ice, the usual scars of something that's wandered through star systems for millions of years. Instead, it showed something smooth. Too smooth. At first, no one reacted. It looked like a glitch, a bright patch of reflected sunlight that had blown out the camera sensor. But as they zoomed in, layer by layer, the glow didn't fade. It sharpened. And the shape underneath became clear, like a hidden face rising through dark water. A surface this smooth shouldn't be out here. Not on an object that's been beaten by cosmic debris, frozen by deep space cold, and roasted by wandering too close to stars. Yet this patch was perfect, almost polished. And it stretched across kilometers like a mirror laid onto the skin of the comet. No one spoke for a while. In the control rooms where the data streamed in, from Hawaii, from Chile, from Australia, a quiet tension pulsed through the air. You can feel when a room changes. When curiosity turns into unease. When questions stop sounding scientific and start sounding personal. Because the moment you see something smooth in a place where only chaos should exist, you're forced to ask, who made it smooth? As the scans continued, the surprise deepened. The bright patch wasn't alone. Another appeared along the equator of the object. Then another. Each one shining like a cold, hard plate catching sunlight. And when the data was overlapped, when the reflectivity maps were stacked and aligned, a shape formed, faint, geometric, and impossible to explain. It wasn't random. Nature doesn't draw straight lines that stretch for miles. It doesn't carve angles that meet perfectly, like the corners of a structure. Yet here, on something drifting through the ecliptic, a pattern was taking shape. A pattern that looked arranged. Some scientists blamed coincidence. They said ice can sometimes fracture in ways that reflect light. They said the angle of observation can create illusions. They said anything to stay grounded. But you could hear the doubt in their voices. Because every new scan sharpened the symmetry. Every new model made it harder to pretend this was natural. Late at night, after most people had gone home, a small group of researchers stayed behind. They watched the scan replay again and again, each time slowing it down a little more. They traced the edges with shaking fingers. They whispered theories they didn't dare write on official reports. The room glowed with monitors and tension. It felt like waiting for a truth no one wanted to meet. One scientist finally said what everyone else had been avoiding: rocks don't organize themselves. And when that sentence hit the air, something shifted. Because once the idea of arrangement enters the room, your mind can't help but wander toward the word that follows it. Artificial. A word that's heavy. A word that carries history and fear and wonder. A word that no one wants to say first. More observations followed. Radar scans revealed that the shiny surface wasn't a shallow layer. It had depth, like a shell or plating or armor that wrapped around something unseen. And beneath that shell, the radar waves scattered, as if hitting chambers or cavities or structures. Each new discovery pulled the scientists deeper into something they weren't ready to face. But the reflectivity was the part that haunted them most. Because there was a rhythm to it. When 3I/Atlas rotated, the bright patches lit up in sequence, first one, then the next, a cold shimmer sweeping across the surface like a lighthouse turning through fog. It felt like a signal. Not the kind you decode, but the kind you notice through instinct. Something about the timing felt intentional, like the plates were meant to catch sunlight at specific angles. Like they weren't just there to exist, but to be seen. People outside the observatory started whispering too. Reporters caught wind of the anomaly. Online communities built theories faster than the scientists could disprove them. And slowly, the story slipped out of the quiet world of measurement and into the louder world of speculation. But inside the labs, the mood was different. It wasn't excitement. It wasn't fear. It was something in between, the weight of knowing you've crossed a line you can't uncross. When a pattern appears in the noise, you start questioning everything you assumed was random. Night after night, the reflectivity maps grew clearer. One scientist described it like watching frost form on a window, soft at first, then sharp, then undeniable. The shapes became angles. The angles became outlines. And the outlines began to look like pieces of something made, not born. One plate curved in a way that hinted at purpose. Another piece aligned with the comet's rotation, as if designed to catch heat at a certain moment. Another seemed to fit into the thermal pattern they had already discovered, the one that pulsed like a heartbeat. The room of scientists grew quieter as the picture became clearer. The universe felt bigger. Closer. More complicated than they had ever believed. Every childhood story about visitors or machines or watchers came flooding back, not as fantasies, but as possible explanations. Of course, no one wanted to jump to those conclusions. Even the bold minds hesitated at the thought of calling this what it looked like. The moment you suggest intelligence, you stop being a scientist and become a storyteller. And that's a line that people fear crossing. But the pattern on 3I/Atlas didn't care about their hesitation. It kept shining. It kept aligning. It kept rotating like a slow, cosmic message. And eventually, the question everyone tried to avoid became the only one left. If this is arranged, then arranged by who? The scans never answered that question. They only opened the door wider. And as the object drifted closer to the sun, the plates grew brighter, like they were waking up, like they were preparing for something. In the end, the scientists were left with a truth they didn't want but couldn't ignore. Reflectivity doesn't lie. Geometry doesn't lie. Patterns don't lie. Something out there had a hand in this. And as 3I/Atlas moved across the sky, shimmering like a silent machine, the world waited for the next clue. Because if the surface was artificial, what else might be hiding underneath? The answer, whatever it was, felt close. Too close. And the next discovery would push them past mere suspicion, into something far more unsettling. There's a rule in astronomy that almost never breaks: an object in motion stays in motion, predictably. You chart its orbit, you plot the curve, you watch the sky follow the math. It's simple. It's clean. It's one of the few things in the universe that behaves the way we expect. But one quiet night, in a dim room filled with blinking monitors, that rule cracked. And it cracked because of 3I/Atlas. For weeks, every model said the same thing. The object should glide through its path like a stone skipping in slow motion across the solar system. No surprises. No deviations. Nothing strange. But then, as scientists pulled up the newest trajectory data, the dots on the screen didn't fall where they were supposed to. They drifted. They bent. They slid away from the curve like iron filings pulled by an unseen magnet. At first, people thought it was just bad data. Maybe a telescope was out of calibration. Maybe a computer algorithm had glitched. But when they checked the numbers again, and again, and again, the truth settled in like a cold breath against the back of the neck. The orbit had shifted. Not by a little. Not by chance. By intent. Something about the motion felt wrong. A natural object doesn't decide to change course. It doesn't hesitate. It doesn't weave. It doesn't turn its head to look at something. Yet 3I/Atlas began drifting, softly, silently, away from the path gravity carved for it. The first deviation was small, barely noticeable. But small became larger. And larger became undeniable. Soon the models on the screen stopped matching reality. Every prediction line frayed like a loose thread. The curves twisted out of shape. Equations that always worked now buckled under something they couldn't account for. In one observatory, a young analyst replayed the new data over and over, zooming in so far the object became a single pixel. But even at that size, she saw it, tiny movements that didn't fit any gravitational pattern. Movements that felt like steering. She didn't say anything at first. She didn't want to sound dramatic. Or foolish. But deep down, something in her chest whispered the truth: rocks don't steer. Across the world, scientists were having the same quiet realization. They watched the path of 3I/Atlas curve like a slow, deliberate breath. It slid away from the ecliptic, then drifted back toward it, almost like it was exploring. Like it was choosing. Phone calls started in the middle of the night. Emails with subject lines that read, "Urgent, check this, are you seeing this too?" There's a strange kind of fear that only happens when something breaks a rule you thought the universe never touched. And that fear rippled through every lab, every observatory, every dark room filled with screens. One researcher, exhausted and pale after hours of recalculating, leaned back in his chair and whispered, "It's moving like it has somewhere to be." No one wanted to hear that. Because the moment you say an object has intention, it becomes something else. It stops being a visitor and starts being a message. And messages always come from someone. But the orbit kept breaking. Models that had been rock solid for centuries collapsed under this strange, drifting path. Scientists tried adjusting for unseen forces, solar wind, dust jets, hidden mass, but nothing fit. The object wasn't reacting to anything. It was acting. Some researchers suggested a natural explanation. Maybe a large pocket of gas was venting from inside the object. Maybe sunlight was pushing it unevenly. But those theories only worked on comets. And 3I/Atlas wasn't behaving like one. The reflectivity plates, the heat pulses, the geometric patterns, none of those matched a fragile, icy body. People began comparing the motion to something familiar. A probe adjusting its course. A drone shifting direction. A machine testing its controls, slowly, carefully, like something waking up after a long sleep. When word of the broken orbit leaked to the public, it didn't explode like other news. It spread quietly, shared between friends, whispered across online forums, tucked into late-night conversations. It had the weight of a secret that felt too fragile to shout. And while the world tried to make sense of it, the object kept moving, changing its path by just enough to stay mysterious. Every time scientists thought they understood the new trajectory, it shifted again, almost like it was staying one step ahead. The motion wasn't sharp or sudden. It wasn't wild or aggressive. It was smooth. Graceful. Like a quiet hand guiding it through space. And that bothered people more than anything else. Because randomness is comforting. Predictability is comforting. But controlled motion out there, is something else entirely. One night, in a dim control room lit only by screens, a senior astronomer stared at the new data and pressed his palms into his eyes. His voice was tired when he said, "If this is natural, then nature is trying very hard to behave like something artificial." And that thought sank into the room like a stone into deep water. Because if the orbit wasn't broken by chance, then something was breaking it on purpose. Still, no one dared to claim the obvious. Even the bold thinkers stayed quiet. Calling it steering felt too big, too heavy. It felt like stepping over a line the world wasn't ready to cross. But the universe doesn't wait for us to be ready. In the following days, the shift became even clearer. The object slowed slightly as it approached a region of space where nothing should matter, no gravity wells, no bodies, no hazards. It adjusted its angle by a fraction, almost like it was lining itself up. And then it drifted into a new path that none of the models predicted. A path that seemed to lead, somewhere. Scientists stood over the data in silence. They looked at the path, then at each other, as if hoping someone would laugh and call it a mistake. But no one did. No one could. Because deep down, everyone felt the same truth rising inside them like a tide. This wasn't a coincidence. This wasn't an error. This wasn't a comet losing its balance. This was guidance. And as 3I/Atlas carved a new line across the darkness, slipping out of every equation ever written for it, the world waited. Not for answers. But for the next move. Because once something begins steering itself, it also begins choosing its destination. And whatever 3I/Atlas was, it had just chosen one. The question now was simple. Terrifying. What, or who, was it moving toward? There's a kind of quiet in space that most of us never think about. Not the peaceful kind. Not the comforting kind. This quiet is heavier, older, almost alive. And for the scientists studying 3I/Atlas, that quiet became the center of everything. Because when the light pulses began, those perfect flashes timed to the millisecond, the world expected sound to follow. A message. A frequency. A whisper carried through the radio waves. But the antennas heard nothing. It wasn't normal silence, the type you get from empty space. It was deeper. Cleaner. A silence that felt like something was missing, or being removed. When the first flash appeared on the monitors, every radio dish across 3 continents turned toward the object, hoping to catch even the faintest trace of a signal. But what came back wasn't static. It wasn't noise. It was the purest kind of nothing, so flat and so perfect that one engineer swore the instruments had simply died. They hadn't. And that was the part that bothered everyone the most. The light would flare, sharp, precise, cold, and then the world would lean in, waiting. Waiting for a sound. A hum. A ripple. Anything. But instead, the airwaves turned into a void, a silence that wrapped around the signal like a wall. Some scientists tried to explain it away. They said the object was too far for radio waves to reach us. They said maybe the pulses weren't messages at all, just reflections or random flares. But deep down, no one believed that. Not after everything else they had seen. The thermal patterns. The reflectivity plates. The impossible orbit. Nothing about this object was random. Night after night, the antennas kept listening. Giant dishes pointed toward the cold darkness, waiting for a whisper that never came. And as the silence stretched from seconds to minutes, from minutes to hours, that quiet started to feel intentional, as if something out there had chosen light over sound. As if it wanted to be seen, not heard. One researcher in New Mexico described it best. She said, "It's like someone knocking, but refusing to speak." And once she said it, that idea spread through every lab like a slow, unsettling truth. Because knocking isn't random. Knocking means intention. Knocking means you want attention. But silence after knocking, that means something else entirely. It means restraint. It means control. It means choice. Across the world, people stared at the graphs and timelines of those light pulses, trying to understand why an object that behaved like a machine would communicate through photons but not through sound. Some believed it was a message coded in brightness, a language of light, pure and simple. Others thought the silence was the message itself, a warning wrapped in emptiness. In one observatory, an older scientist sat alone long after everyone else had gone home. He replayed the pulse sequence frame by frame, watching the brightness rise and fall in perfect rhythm. His headphones stayed on, even though they delivered nothing but a dead, chilling quiet. And at some point, he whispered to himself, "This isn't silence, it's waiting." The idea stuck with him. Because there's a difference between something being quiet, and something choosing not to speak. What if 3I/Atlas wasn't ignoring the antennas? What if it was listening to them? What if the silence was deliberate, a pause meant for us, a space left open for a reply we never sent? But how do you answer something you don't understand? Researchers tried broadcasting simple tones. Then complex signals. Then mathematical sequences. None of it mattered. The object kept pulsing in light and staying silent in sound, like a heartbeat that refused to echo. As the days passed, the silence became its own kind of signal. The absence felt too deliberate, too perfect. Natural silence is messy. There's always static, cosmic noise, background hiss. But what the antennas captured was the opposite, an engineered quiet, stripped clean of randomness. It felt almost protected. That terrified people more than any sound ever could. Because sound can be decoded. But silence? Silence leaves you alone with your own thoughts. The deeper the silence grew, the more it felt like the object was hiding something in the gaps between each flash. Those gaps were identical in length, never shorter, never longer, like a clock ticking in reverse, marking time for a purpose we couldn't see yet. Online forums exploded with theories. Some said the object was testing us. Others believed the silence meant we weren't the intended audience. That maybe the pulses were meant for someone else entirely, someone who knew how to read light without needing sound. But inside the observatories, the mood was quieter. Heavier. Scientists started losing sleep. Not because of fear, but because of something stranger, curiosity mixed with dread. The kind of dread you feel when you know something is trying to communicate, but you can't tell if it wants to help you, or warn you. Every time the pulse hit, a sharp spike lit up the screen. And then the silence came, sweeping across the radio channels like a cold wind. It felt like an inhale with no exhale. A sentence missing its last word. A signal waiting for a response that humans weren't able, or allowed, to give. Some nights, the silence felt so deep that scientists turned down the volume, even though there was nothing to hear. The emptiness was that unsettling. It was like standing in a room where someone had been speaking, and suddenly stopped the moment you walked in. One young technician said the silence reminded him of standing underwater. Everything muted. Everything distant. Everything held back. He said the pulses felt like flashes from above the surface, bright, sharp, impossible to ignore, but what came after them was that heavy pressure, the kind that makes your heart race, because you don't know how long you can hold your breath. Eventually, one question rose above all the others, whispering through every lab and every late-night conversation: why would something choose light over sound? And the more they thought about it, the more the answer felt chillingly simple. Light travels forever. Light can be seen across galaxies. Light doesn't need a listener, only an observer. But sound requires closeness. Sound requires presence. Sound means whoever is sending it, is near. Maybe that's why the silence felt heavier with each passing day. Because if the pulses had carried sound, it would have meant the object was reaching out to us, intentionally. Instead, it stayed distant. Watching. Flashing. Pausing. Silent. And in that silence, hidden between each bright pulse, the world began to wonder if the object wasn't trying to speak, but trying to measure us. Waiting for a reaction. Waiting for something we didn't understand. The silence didn't stay empty forever. But when it finally broke, it wasn't with sound. It was with something far more unsettling, something that made the world realize the pulses weren't the message at all. The silence was. Sometimes, the universe gives us a trail to follow, only for that trail to fade into nothing. And that's exactly what happened when scientists tried to trace the path of the strange wandering object. At first, they were sure it had to come from a familiar place, a star, a system, a warm cradle of gravity that could explain why it existed at all. But as they pushed the data backward, day by day, year by year, the path didn't lead to a birthplace. It led to a void. Not a quiet empty space like the gaps between planets. Something far colder. Far lonelier. A stretch of interstellar darkness where no stars shine for millions of miles. A region so still that even dust seems to hesitate passing through. The kind of emptiness that makes you wonder if the universe is hiding something, or if it never meant for us to find it. At first, no one wanted to believe it. Objects don't just appear. Everything comes from somewhere. A planet forms in a disk of gas. A comet breaks from a star's icy outskirts. Even cosmic debris carries fingerprints of the place that shaped it. But this traveler didn't. When scientists ran the simulations again and again, the answer stayed the same. Its path didn't cross with any known star system. It didn't brush against a gravitational field strong enough to toss it into space. It didn't escape from a birthplace we had simply not noticed yet. It came from a direction where nature has nothing to give. So the question grew heavier: if it wasn't born from a system, then where did it begin? The more they studied its motion, the stranger it became. It traveled like something that had been moving for a very, very long time. Not drifting. Not tumbling out of control. But gliding, almost as if it had been sent. Its speed told a story of distance far beyond what any ordinary cosmic rock could survive. And its shape, whatever it truly was, seemed too clean, too sharp, too intentional to be the product of random space violence. Yet even with all those clues, the universe kept its mouth shut. The trail pointed deeper into the void, a place where ancient light from nearby stars never reaches. Imagine being lost in an ocean so dark you can't see the water around you. That's the kind of environment it came from, a cosmic desert. But deserts, even empty ones, leave marks on the things that pass through them. So scientists checked. They looked for heat signatures, for chemical scars, for anything that might betray a hidden event, a forgotten star explosion, a collapsed system, a wandering cloud that could act like a birth chamber. Nothing. No dust. No radiation. Not even the faintest fingerprint of a star that died long ago. It was like the object had been walking alone through the universe for ages, untouched. The more they examined it, the more a quiet suspicion grew. Maybe the reason we couldn't find its home, was because it never had one. And that idea, that something in the universe could exist without an origin, shook people in a way numbers and graphs never could. Because everything in the cosmos is part of a cycle. Stars are born, they shine, they die, and from their ashes, new stars return. Galaxies collide, worlds form, lives begin, and in their own way, they end. Yet this object didn't seem to belong to any cycle we understood. Some scientists wondered if it had come from a system so old, it no longer existed. Maybe its home star burned out eons ago, leaving nothing behind but a dark memory floating through the void. But even that theory felt too gentle. Too normal. A dead star still leaves footprints. A collapsed system still bends space. But this region didn't just look empty, it looked untouched. And that's when a deeper question began to whisper through the labs: what if the object started somewhere that wasn't a system at all? What if it came from a place we don't have words for yet? A place where matter behaves differently, or where the rules we trust don't apply. It's strange how humans react when faced with something like this. Some felt fear, the quiet kind that settles in your stomach when you realize you've been assuming the universe plays fair. Others felt excitement, because mystery is the fuel of discovery. But most felt a kind of awe, a soft awareness that we were brushing up against something bigger than our charts and telescopes. As the object continued its slow, patient journey, the silence around it grew louder. Not the kind you hear in an empty room, but the cosmic kind. A silence that makes you wonder if the universe is watching us watch it. A silence that feels like the pause before a truth too big to understand. Tracing its past didn't bring answers. It brought questions. Why was it alone? Why was it wandering? Why did it move like it had a destination, even when its origin was nothing but darkness? And maybe the most unsettling question of all, was it truly alone, or was it simply the first? Because if one object could emerge from a place with no stars, then others could, too. Hidden travelers drifting across the cosmic ocean, each carrying a story older than our sun. Each moving through regions where light itself forgets to visit. But for now, all we have is this one. A lonely messenger with no home to return to. A wanderer that began in a place we can't point to on any map. Its journey is still unfolding, and its silence, that strange, heavy silence, keeps following it, as if guarding a secret we aren't ready to hear. The universe is full of mysteries, but this one feels different. It feels like the beginning of a new kind of question. The kind that changes how we see everything else. And as we move into the next chapter, one thought lingers like a faint echo in deep space. If something can begin without a home, then what else is waiting out there in the dark, ready to be found? There's a moment, in every great mystery, when a quiet idea slips into the room, and suddenly everything feels different. It doesn't shout. It doesn't demand attention. It just sits there, heavy and patient, waiting for someone brave enough to say it out loud. For weeks, scientists had been circling around the same strange clues, the uneven heat patterns, the steady flashes of light, the way the object seemed to correct its own path, as if choosing where to go next. And then, one evening, a small team finally broke the silence. They published a paper with a simple, terrifying line. This may not be a natural object. It might be a machine. The moment the words appeared, the world seemed to pause. Journalists froze mid-sentence. Researchers reread the line again and again, hoping the letters would rearrange themselves into something safer. But they didn't. And for the first time, people everywhere began to wonder if the thing drifting toward us wasn't just unusual, but built. The idea felt impossible. Machines don't travel between stars. Not ours. Not yet. But the deeper scientists looked, the harder it became to ignore the patterns. The heat signatures weren't random. They rose and fell like something inside was trying to stay alive. Not warm like an engine, but warm like a failing heartbeat. A low, struggling pulse that flickered each time the object corrected its drift. Almost like it was fighting to stay on course. And those corrections, that gentle steering, made even less sense. Natural objects don't fix their paths. They spin. They tumble. They surrender to gravity and hope for the best. But this thing behaved like it cared about its direction. Like it still remembered a destination, even if everything inside it was slipping toward failure. For a moment, the world tried to explain it away. Maybe it was a weird comet. A broken shard of a world we didn't understand. A trick of physics. But deep down, everyone knew the truth: nature is powerful, but it doesn't try. Machines do. And yet, the idea brought more fear than answers. Because if it was a machine, someone, or something, built it. Someone sent it out into the dark, hoping it would reach something. But what? And why now? Scientists tried to calm the panic. They explained that if it was a machine, it wasn't working the way it should. Its pulses were out of rhythm. Its path corrections were weak, clumsy, almost painful to watch on a graph. No machine travels for millions of years and stays perfect. Time wins every battle. When they zoomed in on the thermal data, they noticed something heartbreaking. The object was cooling faster than it should. Parts of it weren't just broken, they were shutting down. Dying. Whatever it once was, it had survived longer than any machine should. And yet, even in its final moments, it kept trying to move with purpose. That was the detail that kept scientists awake at night. A damaged machine might wander. It might drift. But this one? Even broken, it still tried to steer. It still tried to send pulses of light, sharp and steady, like a message written in a language we couldn't read. It wasn't just surviving. It was doing something. Some researchers whispered that maybe the object wasn't meant to last this long. That maybe, somewhere out there, its creators never expected it to drift into a cold desert of space, fighting to stay alive. Maybe they built it with hope, sent it on a journey, and then vanished long before it reached us. Others suggested something darker. What if the machine was never designed to return? What if it was sent out as a scout, a watcher, a messenger, or a warning? And what if whatever built it wasn't gone at all, but watching from a distance we can't imagine? The machine hypothesis split the scientific world in two. Some felt awe, the kind that brings a soft smile in the middle of the night. The idea that the universe might be full of minds reaching out across impossible distances. Others felt a quiet dread. Because our first encounter with alien technology might not be a sleek, perfect vessel. It might be this, a dying machine crawling toward us, carrying a message too old or too broken to understand. Still, one question overshadowed all the rest. If it was a machine, why was it failing? Machines don't just collapse for no reason, especially ones built to travel between stars. Something must have happened. Maybe a collision with dust moving at deadly speeds. Maybe slow erosion from cosmic rays. Maybe something inside it broke long ago, and everything since then has been the slow, patient death of a once great creation. Yet, even as its systems failed, it didn't give up. It kept sending pulses. Kept warming and cooling. Kept steering with the stubbornness of something that refused to die before reaching the end of its story. And that stubbornness haunted everyone who studied it. Because nothing travels this far, this long, only to fail right before the finish line. Machines break, but missions don't. Missions have meaning. Missions have reasons. So if this object had one, we were standing at the edge of that meaning, waiting for a broken traveler to whisper its final message. As the papers circulated through labs, observatories, and living rooms, people everywhere began to imagine the same scene, a long-lost civilization, somewhere in the vast dark, building a machine with trembling hope. They watched it rise. Watched it leave. Watched it fade into the stars. Maybe they believed it would return with answers. Maybe they believed it would find someone. And now, after a journey longer than any human lifetime, it had come to us, barely holding itself together. We weren't ready for that idea. Not as a species. Not yet. But ready or not, the machine kept moving. Broken, but not silent. Fading, but not gone. And as we step into the next chapter, one question hangs in the air like the last echo of a dying signal. If this is a machine, then who, or what, is waiting at the other end of its story? There are moments in space that feel alive. Not the kind of life we know, not the planets that orbit or the stars that burn, but a pulse, a rhythm, something that makes the emptiness feel aware. And as 3I/Atlas drifted closer to the sun, that pulse began to change. Slowly at first, like a whisper stirring beneath the surface, and then faster, sharper, more insistent. It wasn't a noise anyone could hear. It wasn't a light that dazzled. It was a heartbeat, steady, small, and then growing, as if whatever had been dormant inside the object was waking from a long, cold sleep. Scientists first noticed the change in the thermal data. The patterns that had once drifted with calm predictability now started to spike, a warm flare rippling across the surface, then retreating, then rising again. The rhythm wasn't random. Each pulse matched the last with uncanny precision, accelerating as the object approached. The sun. Instruments recorded the motion like a stethoscope pressed to the chest of the cosmos itself. And the deeper the team looked, the clearer it became, the object was reacting. Not to us. Not to Earth. To something else, something nearby, something it could sense, something that was calling it to life. The pulse didn't just increase. It began to compound. Each beat was stronger than the one before. It was like watching a heart remember itself after centuries of silence. And when the final spike came, sharp, sudden, almost violent, the readings jumped beyond every model scientists had. It was as if the object itself had powered up, a switch inside flipping after eons in the dark. The data glowed red on the monitors, and in that moment, everyone watching felt it, something had turned on. But what had been sleeping? What force, what machine, what consciousness inside this lonely traveler had waited so long, so patiently, only to awaken now? The sun wasn't just a nearby star anymore, it was a trigger, a catalyst, a spark that made the object move with intent. The more it neared, the more alive it seemed. The more it pulsed, the more you could imagine it looking around, shaking off the dust of empty space, preparing for what it had been built to do. Scientists tried to explain it. Maybe it was a natural reaction, solar heating, radiation pressure, the way ice or minerals respond to heat. But nothing fit. The light pulses, the thermal spikes, the perfectly timed rotation of the reflectivity plates, all of it accelerated in harmony, like the mechanics of a living machine. No natural object moves with that kind of coordination. And no comet beats with a rhythm this precise, this urgent. Some researchers whispered about consciousness, though they didn't dare put it in a paper. It's like it's waking, one said, voice trembling, eyes fixed on the pulsing graphs. Another nodded in silence. Nobody had a better word. Machine. Probe. Something alive. All of them fell short. All of them felt inadequate in the face of what was unfolding. The room was quiet except for the hum of monitors and the occasional tapping of a keyboard. People leaned closer to the data screens, drawn into the rhythm that had no sound but somehow filled the room. There was a tension in the air, a mix of awe and dread. Something was beginning. Something had survived the vast emptiness of interstellar space, only to come alive now, just as we could see it, just as the sun began to touch it with warmth it hadn't felt for ages. And then came the light. Not just the reflective flashes from before, but a final, sudden flare, brighter than anything measured up to that point. Instruments that had been calibrated for decades screamed in response. It was as if a door inside the object had opened, and a hidden system had booted for the first time in millions of years. Pulses stacked upon pulses, heat spiked across the surface, and the object moved in ways that were more deliberate than anything observed before. Not random drifting. Not passive rotation. It was alive with purpose, as if finally remembering what it was made to do. Researchers stared, some frozen in disbelief, others gripping the edges of tables. There were no alarms, no dramatic noises, just the quiet glow of screens tracking the awakening pulse. And yet, everyone in the room felt the weight of it, the realization that the object was no longer just drifting. It was conscious in some form. It was aware of its environment. It was responding. It had survived the void, the cold, the endless darkness, only to come awake at this exact moment, in this exact place, with the sun as its signal. Speculation ran wild. Was it trying to communicate now? Was it powering systems to send a message, or to defend itself, or to complete a mission we couldn't comprehend? Every new spike of heat, every acceleration in the pulse, was a question the object refused to answer. The pulse was a language we couldn't read, a rhythm meant for a listener we might never become. And yet, there was a haunting beauty to it. Even as fear gripped the team, there was awe in their voices. They were watching the rebirth of something that had traveled farther than anything else we know. Something that had survived in silence and darkness for eons, and now, at last, stirred. It was a cosmic awakening, and for the first time, we could see it. The final spike of the pulse didn't just signal movement. It signaled transition. A shift in energy, a surge of activity. Whatever had been dormant was no longer passive. Instruments detected changes in rotation, in thermal output, even in subtle shifts in trajectory. The object was alive with its own rules now, responding to forces we didn't fully understand. And all of it was synchronized, light, heat, movement, like the heartbeat of a being just stirring from a long sleep. In that moment, the universe felt close. Not threatening, not cold. Close, like it was holding its breath along with us, watching the pulse rise and fall, wondering what would come next. And as the scientists stared at the glowing data, one thought settled over them, heavy and quiet: we are not witnessing a rock. We are witnessing awakening. And yet, with all the wonder, the fear remained. Something had survived the empty void, but for what? Was it returning to a home it had never had? Completing a mission that began before we existed? Or simply powering up, preparing to show us what it truly is, and what it was always meant to do? As 3I/Atlas continued toward perihelion, the pulse kept accelerating, like the heartbeat of a traveler who has waited a lifetime to remember itself. Every spike was a reminder that this object, whatever it might be, was no longer dormant. It had begun to move with intent. It had begun to live. And as the final readings of the pulse streamed across the monitors, one question echoed in every mind watching it unfold. What exactly is waking, inside the heart of this lonely traveler? The answer wasn't in the data. It wasn't in the light, the heat, or the course corrections. It was waiting. Patient. Watching. Preparing. And whatever it is, we might not be ready for what comes next. There are moments in science that feel like magic. Moments when the universe whispers something so strange, so precise, that even the brightest minds can't explain it. And then there was the night of the last observation. The night 3I/Atlas reached the point closest to the sun, and the world held its breath. Every telescope, every observatory, every instrument trained on it caught the same impossible thing. And nobody could look away. It started subtly. A flare here, a pulse there, brighter than usual, sharper than ever. The pulse rate, already faster than anything recorded, began to converge, lining up with a precision no natural process could produce. Then, in a single heartbeat, the flare expanded. Slowly at first, like a glow spreading across a frozen pond. And then faster. Faster. Until it bloomed in perfect symmetry, a geometric explosion of light that seemed deliberate, intelligent, almost alive. It wasn't chaotic. It wasn't scattered. It was designed. Every edge, every angle, every reflection seemed measured, intentional. Telescopes around the world captured the same pattern, the same pulse, the same blinding bloom of light. And as scientists watched, a shiver ran through every room. The light didn't just illuminate the object, it illuminated something deeper. Something almost sentient. It was a final message in the only language 3I/Atlas had been using, light. For minutes, the bloom hovered in the instrument's view, perfect and symmetrical, like a star-shaped signature etched across the void. The heat readings spiked, the pulses intensified, and the orbit adjusted as if the object were aligning itself one last time. Cameras recorded frames that would later be described as impossible, surreal, and terrifyingly beautiful. It was the kind of image that could be printed in textbooks decades later, the kind of event that makes even the most skeptical scientist pause and whisper, "I don't know what we're seeing, but it's extraordinary." And then, just as suddenly as it began, it stopped. Every signal, every pulse, every trace of heat vanished. The light blinked out, the geometric bloom collapsed into darkness, and the object became nothing. Not invisible. Not faint. Just gone. The instruments recorded the silence, a perfect, absolute quiet. It wasn't normal. Not the kind of fade you see with comets or asteroids. This was deliberate. Clean. Precise. Like someone had reached across the cosmos and pressed a switch. Scientists stared at the screens, mouths open, hearts racing. The telescopes continued to point at the spot in space where the object had been, but there was nothing. No reflection. No pulse. No heat. Not even movement. Just a void where something extraordinary had been alive moments before. The room felt impossibly still, as if the universe itself was holding its breath along with them. Some tried to rationalize it. Maybe it had disintegrated. Maybe the sun's heat tore it apart. Maybe cosmic forces erased it. But the symmetry. The precision. The geometric perfection of that final flare made every natural explanation feel inadequate. Nothing in physics predicts a sudden, flawless blossom of light followed by absolute silence. Nothing, except a machine, or something designed, finishing its task. The papers, the forums, the social feeds, all erupted the next day with speculation. What had we witnessed? Was the object destroyed? Or had it completed its purpose, leaving us only with the echo of its final signal? Researchers debated, sometimes heatedly, sometimes in hushed tones, because deep down, everyone knew that whatever 3I/Atlas had been doing, it was no longer doing it for us. The message had ended, the observer had departed, and the cosmos was quiet once more. Yet even in that silence, the event left an impression. People described the experience like watching a heartbeat stop after decades of rhythm, awe, grief, fear, and wonder, all tangled together. The light had been beautiful, yes, but it had also been unknowable, alien in its intent. It didn't comfort. It didn't explain. It only revealed that the universe had depths we had yet to measure, patterns we hadn't begun to understand. The object's disappearance didn't bring answers. It raised questions that lingered like smoke in empty rooms. What had the flare meant? Was it a signal? A warning? A final expression of life from a traveler that had survived the void for longer than anything human eyes could imagine? Or was it something else entirely, something we weren't meant to understand? Astronomers replayed the footage again and again. Each frame seemed to contain information that slipped through comprehension, like a riddle that rearranges itself the moment you think you've solved it. Some nights, after the monitors dimmed and the lights went out, scientists would lie awake, staring at the ceiling, imagining that pulse, that blinding geometric bloom, and feeling it linger in their minds like a phantom heartbeat. And the more they thought about it, the heavier the mystery grew. For all the instruments, all the calculations, all the simulations, there was one certainty: whatever had moved toward the sun, whatever had pulsed and steered and awoken, was no longer there. It had left, vanished, or perhaps transcended some boundary we could not see. And the silence it left behind was as precise and intentional as its final flare. In a way, the last observation became more than a moment in science. It became a story. A story of survival, of design, of awakening and departure. A story that challenged what we believed about motion, about life, about the possibility of intelligence beyond the human scale. And it didn't end. Not really. Because even in absence, the memory of the light, the memory of the pulse, the memory of that impossible bloom, continued to ripple through every mind that had witnessed it. For some, it became a question that would haunt them forever: was that the end, or was it just the beginning? Because the universe doesn't give up its secrets easily. And sometimes, the things we see last are only the opening act. As the data settled into archives, as the telescopes slowly turned away, and as humanity tried to comprehend what had just happened, one thing was clear: 3I/Atlas had left a mark that no calculations, no charts, and no words could fully capture. It had written a story in light, played out across millions of miles of empty space, and then, without warning, gone quiet. And in that silence, the world could only wait. Wait for the next pulse. Wait for the next visitor. Wait for the universe to remind us once again that even in the void, something remarkable is always awake. Because sometimes, the last observation is not the end of the story. It's the first moment we realize we don't understand the story at all. And for those who watched it happen, who felt the rhythm, the bloom, the heartbeat of 3I/Atlas, that realization would never leave them. The object had disappeared. The light had faded. The signal had ended. And yet, in that impossible final moment, it had spoken louder than anything else in the night sky. What it said remains unanswered. The sun rises every day like clockwork. Its light touches everything, warms everything, reveals the familiar rhythms of our world. And yet, just beyond its blinding glare, something vanished. Something that had traveled across the void, something that pulsed and breathed with its own impossible heartbeat, simply disappeared. 3I/Atlas passed behind our star, and then, nothing. No debris. No signal. No flare. Not even a trace of heat to mark its presence. The universe, in that moment, seemed colder than ever. Scientists stared at their monitors, replaying data frames over and over, each hoping for a flicker of movement, a clue, anything that could hint the object had survived. But the instruments recorded only silence. Absolute, perfect silence. A vacuum of information. And in that quiet, the realization sank in: the object wasn't just gone. It had left without explanation, without closure, without even a whisper. The mind wants patterns. It craves cause and effect, origin and destination, reason and meaning. And here was something that had given us all of those things: light pulses, thermal shifts, perfect geometric flares, only to vanish before we could understand. Patterns we had traced across the sky, rhythms we had studied for months, now floated alone, disconnected from their source. Like the echo of a voice long after the speaker has walked away. Theories multiplied. Some suggested it disintegrated behind the sun, shredded by heat we couldn't measure. Others proposed a more unsettling idea: it had completed its journey, and whatever intelligence built it had called it home, or perhaps moved it to another path we cannot see. But nothing explained the precision, the beauty, the intentionality of what we had observed. And nothing explained the absence, the way it erased itself from our view, as if the sun were a veil, hiding not just its path, but its purpose. Every observatory that had followed it now felt empty. Astronomers who had spent nights hunched over screens, tracking the faint pulses, now faced a void that couldn't be filled. Data alone remained, a tapestry of numbers, graphs, and patterns pointing to something extraordinary, yet leaving humanity suspended in ignorance. The object's origin, its nature, its fate, all unanswered. And in that absence, the human imagination filled the silence. Some imagined a machine retreating to the edges of the solar system, recovering from a long journey, waiting for a signal we may never intercept. Others whispered of something more poetic, even terrifying, that we had witnessed a messenger too advanced to comprehend, delivering a story only partially, leaving the final chapter forever hidden behind the sun. The patterns themselves became a puzzle. Every pulse, every thermal spike, every reflective flare hinted at intelligence. But intelligence with what goal? Communication? Observation? Warning? Or simply survival? The truth didn't arrive to meet our curiosity. Instead, it left us staring at shadows, shadows cast by a journey we could trace but not touch. For months, scientists compared the last pre-sun readings, mapping trajectories and thermal cycles, trying to predict where it might emerge on the far side. Models were built and discarded. Every prediction ended in emptiness. The object was gone, leaving only the lingering questions: why here? Why now? Why did it vanish? In that quiet, a different kind of realization settled over the teams tracking it. We had been witness to something far greater than a passing rock or comet. We had glimpsed the edges of a story too vast, too old, and too strange for human comprehension. And even without a conclusion, even without a return signal, the act of witnessing itself became profound. The universe had shown us a pattern, a pulse, a glimpse of intention, and then folded it back into its infinite darkness. Some nights, scientists would look at the sun with a new sense of respect, or fear. Behind its blinding light lay the unknown, the unreachable, the place where answers could vanish as easily as they appeared. And somewhere there, beyond the glare, 3I/Atlas had traveled, unseen, carrying whatever it carried, leaving humanity only with memory and speculation. There is a strange kind of melancholy in that. To witness a mystery and have it recede before understanding arrives is to confront the limits of knowledge itself. We could measure the pulses. We could record the heat. We could watch the light curve dance and swell and spike. But the story, the origin, the final purpose, that remained beyond our reach. A truth that doesn't arrive, a message just out of grasp. And yet, perhaps that was part of the lesson. That the universe is not obliged to answer our questions. That some journeys are meant to be glimpsed, not fully understood. That some messages are fragments, left behind to inspire awe, to spark wonder, to remind us that the cosmos is larger, stranger, and more alive than we can ever predict. Even in silence, even in the absence of debris, even in the void behind the sun, the pulse of 3I/Atlas lingers. In the patterns we traced, in the graphs we studied, in the images burned into our minds, it continues to speak. Not in words, not in explanations, but in presence, in the undeniable fact that something came, traveled, pulsed, and then vanished. And the space it leaves behind is not empty. It is full of questions, full of imagination, full of the haunting echo of a truth we may never receive. So we wait. We observe the sun, we scan the skies, we build instruments and models and simulations, hoping one day to find the other side of that journey. And in the meantime, the mystery becomes part of us. It shapes how we look at the night sky, how we measure the light of distant stars, how we imagine what might exist beyond the edge of our understanding. 3I/Atlas will not return to us. Its signal is gone, its pulses ended, its geometric flare extinguished. But it left us with something far more profound, a reminder that the universe is alive with mystery, that travel across light years is not just possible but deliberate, and that some stories exist only in the act of being witnessed, even if we never understand the ending. And so we stand in the quiet. Alone, yet connected. Our instruments shut down, our eyes lifted to the sun, our minds tracing the impossible paths that vanish in its glare. The debris never comes. The object never re-emerges. Only the patterns remain. Only the pulses, now etched into history. Only silence. The truth doesn't arrive. But perhaps that is the truth itself. That some mysteries are not meant to be solved. That some messages are never fully delivered. That some journeys leave us with wonder, awe, and a question that will echo through time. What vanished behind our star, and what message did we miss? And in that echo, the story of 3I/Atlas lives on, not in sight, not in signal, but in imagination. A reminder that the cosmos will always be bigger, older, and stranger than we are ready to grasp, and that sometimes, the most haunting truth is the one that never arrives.